axis type of robots. Next is SCARA robot. What you're looking here, the last one, SCARA robot, is exclusively used for assembly applications where it can move fast, fast precision, fast assembly applications. Pick and place activity will be very fast. So precision and the repeatability of the task is very fast. So this is the broad categorization of industrial robot what we want to know in the present scenario. Okay, industrial robots. How can we define industrial robots? See, it is so we can't just as an engineers or as a students, technical students, we can't just tell that no, robot is a machine or it is a post lever. Okay, so we can't tell that in a general common way. In fact, we have to specifically code the definition of industrial robot. Okay, so the official definition of industrial robot was coined by Robotics Industries Association (RIA). Previously, it was called as Robotics Institute of America (RIA). So they have coined the industrial robot. How they have coined the industrial robot? So industrial robot is a reprogrammable, multifunctional manipulator which is designed to move any materials, any objects, okay, parts, tools, or special devices through a variety of programs. So a variety of programs can be programmed for the same robot to perform various types of tasks because you can uh, see the robot what you can visualize there, the industrial robot, six axis robot. The same robot can be used for pick and place application. It can be used for loading and unloading application. The same robot you can also program to do welding applications. It can be used for the spray painting applications. Okay, so it can be used for packaging application. One single robot will be performing multiple of tasks. So that is why it is called as multifunctional and it is reprogrammable. Okay, so the other technical name where we can refer industrial robot also as a manipulator because it tends to manipulate the task or the objects. Okay, so it can perform variety of tasks. Industrial robot can perform variety of tasks through the programmed motion or the programmed joints of the robotic systems. So this is a broad sense of industrial robots. Next, humanoid robots. Before going with the industrial robots and the types and technology aspects also, let us also go with some the most what do you say fascinated robots what we are coming across the technology, that is humanoid robots. Yes, of course, humanoid robots is also getting a lot of demands in the present scenario. It is also called as articulate industrial robots. Articulate means because it resembles like a human being. You can see the arm, elbows, wrist, fingers, joints, neck, okay, shoulders, knee joints, everything. So it resembles like a human being. So that is why we call that as articulate robots. Articulate robot. This is the word where technically we have to address the humanoid robots. So these type of robots basically represents the shoulder, elbow, and the wrist of the human being. Robot fingers. Okay, so when you can see the robot fingers, it is called as the end effectors or the grippers basically. So it can be designed just like human beings fingers, human being fingers, or it can also be designed like the two finger gripper, as the robot can have two finger or three finger gripper. So basically that objective is to hold the object, first of all hold the object, grasp the object and perform the pick and place applications. So this is about the industrial robots. Yeah, some of the laws of robotics which we have to know. Okay, so generally, yes, there was a time where people used to be afraid of robots. Yes, of course, it may harm or it can cause some threat to human beings. Okay, it is not user friendly for the human beings. Couple of years or decades. So now the all the robotic systems which is designed basically they have to generally abide about this laws. What is this first law? The first law says that robot may not harm the human being. It should not harm. So since the robot is working with human beings, so it should work in a very friendly environment. It should not harm human beings. The second one is robot must obey human orders. It should not go against human orders. So whatever the orders. So how do we order the robots here? Basically, we give the orders of the robot in terms of set of instructions, coded instructions to perform various type of tasks like pick and place, like loading applications, perform welding applications. So these are some of the orders where it has to obey and abide all the rules, all the instructions given by the human beings. Third one is robot must protect itself. Yes, of course, it should also protect the human being safety. It should obey. Of course, it should not danger or it should not harm itself because the complete the technology and the investment and the components of the robotic system is also equally important. It should also be protected. The robot should also protect itself and also obey all these three laws. Yes, when we talk about the industrial robots, let us understand technically. We have to understand what is this joint and link. Most of you may be knowing about this basic fundamentals. Again, I would like to recapitulate some of the fundamentals of industrial robots. So, at left side, what you can see here is the human arm. So, the red color dot represent a joint, and the two joints are basically joined by a link parameter. So the link is in blue color. Okay. So what is this joint here basically? Joint always, as you know, human, we have different types of joints. Yes, of course, you can see the shoulder joint, elbow joint, and the wrist joint. It helps to rotate or it provides a free movement of the human body parts. Okay. So similarly, based on that aspects, the industrial robot manipulator is also designed. Okay. So the joint is basically a solid body where it provides the free movements or the free motion is possible in terms of degrees. It can rotate to any degree of requirement. Link is a solid rigid member where it joins the two joints or it links the two joints. So it provides stability. That is a strong skeleton or the bone, what we can tell. Okay, it's a strong bone or the skeleton which helps to okay link the two joints and provide stability to provide strength during various robotic applications. So when you look at the right side view here, so the robotic industrial manipulator, what you can see here, it can be very simply explained with joint and one. So industrial manipulator always it will be fixed. Okay, so most of the industrial manipulator will be fixed, and we can also integrate this type of jointed arm to a mobile robot. So that is a different aspect. So generally, industrial manipulators are fixed to the floors, shop floors. Okay. So the ground, on the ground, flat ground, you have a base part. So on the base part, you have the first important member of the robotic system, that is link zero. Link zero is again joined to a joint one. Okay, joint one. So joint one is connected to the joint two with the help of link one. Okay. So joint two again it is connected to the ender form or a fingers or the gripper with the help of link two. So totally we are having uh, three links, that is link zero, link one, and link two. All these are the links are basically solid rigid body which provides high strength and it provides the strong stability for the robotic system to pick and place. And what you can see here, you have about two joints. Okay, so joint one, joint two. So joints provides the motion of rotations. It can be a linear or rotational type of movements. So this is the technical specification part of robot joints and links. Yes, of course, we have to understand what is this degrees of freedom. So we have to to know basic fundamentals of industrial robot. What is degrees of freedom or DOF? So you can see this picture here. You have DOF1, DOF2, DOF3, DOF4, DOF5, DOF6. That represents it has 6 degrees of freedom. How can we define degrees of freedom? In context of mechanics, we can define that it is basically different modes in mechanics or different modes in mechanical manipulator. So it is a typical mechanical manipulator. So where it is a different modes. Okay. So in simple, we can also define very precisely as it is the number of degrees of freedom or the total number of independent movements, or it is the total number of displacements or the aspects of motion. Okay. So how we can define the degrees of freedom? So for example, DOF1. So it is the independent entity. Okay. DOFM. So you can see the arrow mark of the degrees of freedom one. It can move only along that direction. So independent motion. When that degrees of freedom is moving, other need not move. That is DOF 2, 3, 4, 5, 6 need not move. There is no mandatory rules that all the joints has to be moved. So DOF2, it can independently move about that arrow mark. Okay, so it can rotate about that arrow mark. So similarly DOF3, DOF4, DOF5, DOF6. All these are independent movements or independent displacement. So whenever the robot has independent movements and displacement, which has the own entity to move about its the axis to perform a variety of tasks, we can address that as degrees of freedom. So in this case, since it has showing that arrow mark is showing that it can move in 6 possible ways, in 6 possible motions, or in 6 possible displacement. That means this is a typical 6 degrees of freedom manipulator, 6 degrees of freedom manipulator. Okay, so I hope you got the basic parameter of degrees of freedom. Next, what is this work volume? So we have to understand about the work volume of robot. What is this work volume? So work volume is a term basically, it is a space within which robot works. So imagine you have a robot there. So you can see the circular area. So that means the robot can move in that circular area itself. It cannot move beyond that. So it can move in a radial distance. Okay, the robot arm can move in a radial distance. It can also move up and down. It can also extend the arms. You have 3 important types of motion. Okay, so you can see one of the arm. So you can see this arm here. This is a linear motion where the robot can extend the arm to perform any task, and it can also retract the arm. So this is one type of movement. So it can move only in this area. Maximum than that it cannot reach. So this is the maximum reachability. Okay. So you can see this arrow mark here. So it can move downwards and upwards. Okay. So that means it can take the height of this small cylinder. Okay, so it can move only in this height. Beyond that, it cannot move because the design of the robotic system of the robotic links and joints is designed such that it can accommodate only that work envelope. So it can perform only the productivity task within that task, that area. So the maximum reach where the robot gripper can reach in that area is called as work envelope of a robot. Next, drives of, what do you mean by drives of robotic systems? See, when we talk about cars, okay, so you have the regular conventional system, ICE engines, petrol engine, diesel engine. Okay, so the next part of the cars is the LPG, CNG mode, and other is the most fascinated is EV vehicles. So similarly, there is different modes to drive the robots here. So what is the drives of robot here? Basically, it gives the strength or the power. Basically, just like human being muscles. If a person is having more strength or energy, he can perform much better tasks. Okay. So this is about the industrial hydraulic drive system. So it can perform different applications like pick and place applications. So hydraulics means basically it uses the pressurized oil or a fluid. Okay, so it uses a pressurized oil or a fluid to perform various type of tasks. Okay, so as you can see, the Unimet Robot 2000 series, it is basically a hydraulic series, hydraulic arm. This arm basically moves with the hydraulic pressure. Okay, the hydraulic fluid pressure helps to move the robotic arm, extend the arm, and perform the heavy task, heavy loaded task. So you can see the JCBs or you can see the cranes. They use the hydraulic type of the drive system to perform various types of tasks. Next is the robotic pneumatic systems. What is this pneumatic systems? So you know the it is a less power applications when compared to the regular hydraulic system. So the pneumatic cylinder, as it is mentioned there. So the compressed air from the compressor enters into the cylinder, and the cylinder gives out the pressure of the compressed air to the different parts of the robotic manipulator. So where you want to handle a simple component to medium weight application. So this type of applications can be used for pneumatic systems. So when compared to both the aspect, hydraulics and pneumatics applications, for both the aspects, one of the drawback what we can tell that is leakage problem. So when we talk about the hydraulic robotic system, of course, it is made up of the fluid system. The cylinder is basically filled with a pressurized fluid system, so it tends to perform leakage. Maintenance issue is very high, space consumption is very high, and you have noise, and it is quite what do you say, untidiness, or it is not clean. The area is not clean while performing various types of tasks. So pneumatic system again, you have a leakage problem, and it is not as messy as hydraulic system because air is a medium where it can escape and through the medium, and it does not cause much trouble when compared to hydraulic system. The compressed air is basically used to perform simple applications like pick and place applications. Okay, so loading applications and all. Next is electrical drive systems. Of course, the present industrial robot what we have is basically it is made up of electrical drives. So we are ruling out with hydraulic drive systems, pneumatic drive systems because electrical drive system is having far advantages when compared to hydraulics and pneumatics because no leakage problem, no sound, it consumes very less space, it is very precise, compact in nature, and any type of precision movement can be done. Okay, and the controlling is also very easy when compared to hydraulics and pneumatics, and it does not need extra what do you say, power zone like fluid tank. It does not need a fluid tank, or it does not need a what do you say, a pneumatic tank, compressed pneumatic air to supply the air. So in different joints of the robot, we can incorporate servo motors and stepper motors for performing various types of tasks and applications. Based on applications, the motors and electrical drivers will be selected. So, when we talk about the industrial robotic companies, these are set of leading robotic companies like ABB Robotics, KUKA, Fano, Yaskawa, Kawasaki, Epson, Nachi. You have a Mitsubishi robots, and you have a Dobot robot. You have a Seiko robot, Panasonic, Hyundai. Different types, Omron Robotics. So the first two lines are most popular and globally competent robotic players, what you can see here. And of course, even our country is also contribute towards robotic, and Tata is also Tata machines is also contributing towards the robotic. We do have Tata robots also, and it is also contribute towards the industrial robotics applications. Coming to the industrial robot installations, if you take the this is the latest statistics which I got data from the International Federations of Robotics, where China is using the maximum percentage, about 54% or 55% of globally, where it is the largest industrial robot consumption. So about 80% of the market is basically used by the Chinese industries, Korea, Japan, Germany, India, Italy, and Mexico and other parts of global uh, players. So before that, I would like to show you a glimpse of industrial robot applications. Let us understand what is this industrial robot application and how it can work in industries. I'll just play a video for you, so we can just have a video and come back again. Is it visible, all of you?
Yes, sir. It's visible, sir.
So again, you can see the industrial robot where it is playing a vital role in manufacturing, automotive manufacturing industry. It's a simple case study to understand how the robot is playing or contributing towards the automotive industry of Audi. Is it visible? Later visible? Hello.
Yes, sir.
Thank you. Yes, we got to know about the industrial robots applications, and it has grown up in such a way that it has increased the productivity, it has improved the precision, it has improved the what do you say production rate basically, and repeatability is also very high when we take about the industrial robots. Okay, so let us try to understand technically. We can't go in detail of industrial robotics applications technically, and so this is a overview, basic structure to understand technically as a engineers how the industrial robots has been classified. So the first one is payload capacity. So any robot, if we consider industrial robot, basically each robot will be having the total weight, maximum weight that robot can carry or manipulate. Okay, for example, about 10 kg or 15 kg. More than 10 kg or 15 kg, if you give a load to the robot, what happens? it is going to fall. Okay, so for example, you stretch your hand, and if they give you about 500 kgs of weight, what happens? You will just fall down, or you will bend your hand below. Technically, we call that as deformation. Okay, the strength gets reduced, or you deform the load. So it is not a capacity. Again, reachability, as I told you, work volume. So the maximum distance where the robot can reach, see, each human beings have different heights. Okay, the taller person can reach the taller space. If you have any tall spaces where you want to take a book or some objects, so generally we search for a taller guys, because they have longer lengths of their hands, so they can reach their components very easily. That is the simple concept of reachability. It is a maximum reach of the robot of an end effector. Okay. Next, repeatability. See, if you give a task to do some packaging, or to put the screwdriver to any machine, how long you can do it? Okay, so you can't do it consistently, because we are all human beings. We can't do it consistently, repeatedly. We will make some mistakes, and will consume more time. Fatigness will come. So next is weight. The total weight of the robot includes the manipulator and controller weight. So it is a total weight of the robot, including the manipulator and the controller. The total body or the structure manipulator weight, and we will give the controller weight. So next is coming to the current trends in robotics. Okay, so when we talk about the robotics, basically we have autonomous mobile robots. We call that as AMRs, automated material handling vehicles. So it is unmanned. So you take up Walmart or any huge warehouse systems. So all the pick and place of the different goods or items in the entire shop floor is completely unmanned. So that is the autonomous mobile robots. Again, you have a intelligent robotic systems, where you have the artificial intelligence or the algorithms which is built into the system, which can perform various types of complex tasks, and it can take, or it can think intelligently, take the decision by itself. Next is cobots. I'll explain what is this cobots or collaborative type of robots. So next is robotics as a service. So robotics can also be used in various types of service systems, and it can be used in terms of IoT applications. Next is robotic cybersecurity. It can also be deployed for security aspects, and we can also see some of the drones applications, unmanned applications like the delivery of the online objects, or it can also dispense the mails in US, Internet of robotic things. So you have the Internet aspects which is connected to the robot, where it can get the real-time data analytics and perform based on the real-time situations. Next is humanoid robot. Next is automated guided vehicles, which already I told. Automated guided vehicles or autonomous guided vehicles is more or less the same. Next is assistive robot. So robots is also used in assistive for elderly people. Next is the role of industrial robots in smart manufacturing. What is the smart manufacturing here? So, smart manufacturing system is that the robots is deployed in manufacturing aspect, where a robot will take the real-time data from sensors, so from the sensors of various parts of the manufacturing systems, and that various inputs of the sensors, like what is the time required to complete the task of the machining part or welding applications, and real-time data analytics. So that real-time data analytics, it will give you the complete information where the robot has to perform the task, what is the uh, task which is already being completed, and what is the pending or the future required task. And it will give so specifically that it will not miss out any of the tasks. See, welding a very minute component of the task what the robot is doing, it is highly impossible for any professional or any skilled operator. So obviously we'll do a unskilled type of job, okay, there. So that is why this type of robotics or mechanized applications is very important parameter. How it is called as smart manufacturing system? Because you have connected systems, you have connected AI systems with data analytics, with the sensor input, that is IoT, that is industrial Internet of Things. So it is nothing but industrial Internet of Things, because the machines are connected with the supervision of human beings, with the data analytics, with the sensors input, with the Internet of Things, with the maintenance aspect. And the smart manufacturing system is also useful with the help of predictive maintenance. It can tell you when the robot is going to have some malfunctions, or when there is a robot will have some problems. It will predict the future. Okay. It can predict any problems which is occurring during manufacturing process. So that type of predictive is also important. So by doing also all the aspects of this smart manufacturing, the ultimate objective is that you can get the high quality without compromising any of the aspects. So that is why the cost of industrial automation, the cost of implementing robots initially will be very high for any industry. Next is robot operating systems, and the current trend, what all the industries are looking forward is that, along with the programming aspect, along with the mechanical designing, mechanical building of the chassis of the robot or the manipulator, links, joints, everything. The present scenario where some of the robotic system which they are asking, like Fanuc or ABB or Ati Motors from Bangalore, or Yashkawa, they are looking forward for the students who are well versed in robotic operating systems. So we are one step ahead. That is ROS2. ROS2 is basically an open source of robotic platform, or robotic programming software. It is designed with the parameters where it is reliable for any type of applications. It can scalable. You can scale up any type of applications. You can increase or decrease the parameters. Okay, and it is a production ready robotic system. It is always ready for the production system. So it can overcome many of the limitations of ROS1 because it can have add-on features. It can have a scalability. It can have a security part. It can increase the production of industrial automation systems. Coming to the other part of ROS2 specifications is that it can support multiple of robots. It will not support only one industrial robot. So series of connected of robots can be connected with the help of distributed computing. So robot operating system, that is ROS2, will basically provide you a distributed computing environment. Okay. And so what is this distributing computing environment? So basically, it is a communication middleware where you have the data which will be distributed throughout the system. Okay. So while we distribute the data throughout the system using ROS2, what happens? The data can enable fast. Okay, it is reliable, and the communication can be scalable. You can deploy more number of robots, n number of robots, because it is able to communicate to each and every multiple of robots. So that is the advantage of the data distribution service. So it is designed to support real-time robotic applications. It is a built-in security system, and it also supports for simulation environment. So sometimes it is highly impossible practically to develop a real-time system. So we can deploy the robotics system or the software, and we can implement that using a simulation environment like Gazebo software, or any other Copelia sim, or the software. We can create the industrial environment and see how the real-time robot works. Okay, and other important parameters that you can also integrate very important hardware components of robot, that is sensors, lidar cameras, manipulators, etc. And so, which are the feasible part of ROS2? It is compatible for Linux, Ubuntu, Windows, MacOS, and other embedded operating systems as well. Next, we move on to the top global robot trends. The first one is AI and machine learning. Second is cobots, in a new application. Third is mobile manipulators, digital forces, digital twin, and humanoids. So this is the what do you say incremental trend which has been going on. So AI and machine learning, cobots, collaboration robots, mobile robots, manipulators, digital twin, and humanoids. So, what is this soft robots? The current trends is the soft robotics. See, in order to hold a plastic bottle or in order to hold a glass, it is only the human fingers. So we can effectively hold a glass very. The object is very fragile. Okay, very sensitive. So how? Because the texture of a human being is such that it is very flexible, soft. Okay, and it is a deformable type of material, a human skin. Similarly, due to the composite materials of bio composites, we are in the silicon industry, we are able to get a very flexible and deformable materials. And how this type of soft robots is basically evolved, it is only inspiration of bio inspiration. Okay, it has been derived by bio inspiration. What you're looking here is basically inspired by the human fingers, right? So it has 5 fingers, and how we hold the pen, okay, how we grip the pen naturally as human beings, that is the inspiration, that is the bio-inspired human beings, how the human being holds the bottle. And octopus, I think you've seen the octopus, and it can hold the object of the shape. The complete the fingers of the octopus takes the shape, entire shape, so that it can securely hold the object, and it can take the adaptability. It can adapt to any required shape. Okay, next is the future, what presently is going on, and the future also will be there. The first one, what you're speaking is Zeko robot. Basically, it is just like lizard. It is also bio-inspired and star-shaped part. It is an adhesive feet robot. This robot is designed such that it can climb like a lizard with a very adhesive grippers. It can be used for various surveillance applications. Second is the quadruped unmanned robot or a robotic dog. Boston Dynamics, US, they are tremendously working on these type of robots where it is used for defense purpose, for carrying the loads of the defense, or to send the quadruped to the unmanned area to collect the data, real-time data, and basically for the storage of the luggage or any the defense items can be done with the help of the robotic top system. Next is burrowing robot. So it is just like earthworms where it can insert inside the earth, and it can know the different parameters of the soil, and it can know the moisture content, it can know the defective soil or poisoned area for the research and development. Next is the underwater robots. So the underwater robots can basically, again, it can be used for excavation and research of the untouched areas of the underwater, where it can explore the items. Next is robotic pollinators, just like bees, it is nutrients part of the agriculture. Next is humanoid robot. Next is soft robotics. The future, what you're looking here is that, see, if we give the hard material, if we give a metal, the obviously the robot cannot hold it. Either it will crush or it will break the object, like apple or the drug bottle or a rubber or a football or whatever it can be. It is going to either crash the material or it will hold very lightly. So we know very correctly, if you want to lift up a huge say, if you want to lift up a TV, okay, so we want to know how we'll know how to apply the load, and what quantum of load, what is the quantity of load we want to lift up using hands. Okay, so if you want to lift up a uh, take or carry the apple, so we know what is the quantum of force to be applied. Similarly, so this soft grippers is basically, again, it is a bio inspired soft grippers. It is very ideal for holding irregular objects basically. To be very clearly, all these soft grippers are basically used for holding irregular objects and like foods or electronic components where the component is very sensitive. Okay, and the material which this type of grippers which is made is pure typical mechanization, steam and water power systems in the year 1800s. Next is Industry 2.0, where it is a mass production with electrical power system assembly. Next is Industry 3.0, where the interventions of the robotic manipulators with computer systems production with electronics integrations evolved. That was in the early 2000s. And next is Industry 4.0. Industry 4.0, it is cyber physical systems where you have the IoT or industrial Internet of Things, which is having a networking, and that has enabled the physical robotic systems with the cyber systems. Next is Industry 5.0. Industry 5.0 is the extension of 4.0. Along with that, the human beings are basically associated with the robots. They work with robots together to perform the specific task. So collaborative systems or customization can be obtained here. So this is industrial revolutions. So what is Industry 5.0? Industry 5.0 basically it is combining human activity with the advanced technology. See, we can see this picture here. The human beings is working together with robotics. So the main agenda of Industry 5.0 is human centric, where the human being, the creativity or the intelligence or the thinking capability or the decision making of a human being is made into a technology, is made understood to a technology of the machines in order to increase their repetitive task, or in order to be resilient systems, in order to be a resilient systems of the robotic system. So the key principle of this Industry 5.0 is the human beings will be working together with the machines. Okay, so which includes which can make more sustainability, and it creates better creativity to handle the robots more creatively. So it's a small difference between Industry 4.0 and 5.0. Industry 4.0, the focus will be automation and smart factories. 5.0 is human machine collaboration, basically collaborative robots. Technology for 4.0, IoT, AI, big data, and the main attraction is cobots and digital twin for 5.0. Production, mass production, and efficiency for Industry 4.0. Customization and personalization is possible because human being is customized and he's making a creative environment in the Industry 5.0. Energy efficiency is possible in case of 4.0. Overall circular economy and waste reduction can be possible with respect to 5.0. Minimal and monitoring of automation can be done in 4.0. Central role, and it can assist the technology with human intelligence system. Flexibility, fixed automation system in case of 4.0, and adaptable and modular production system, because you have a collaborative robots which will be working to make more adaptable and modular production system. So this is the broad classifications of Industry 4.0 and 5.0. What is this digital twin technology? See, digital twin is nothing but it is creating environment or virtual real-time replica of a physical object, whether it can be a human being, whether it can be aircraft, whether it can be an automobile car, whether it can be a cell phone or laptop, whatever it can be. A virtual environment can be created, okay, of the physical system, and that physical system can be monitored. You can visualize the performance, and you can also optimize the operations on that. So you can simulate the behavior. For example, if you want to create the aircraft of that, you can create the object and you can simulate. You can simulate what is the dynamics that the flight can travel with respect to so and so kilometers of speed in the altitude, so and so altitude. What is the dynamics? What is the design of the nose of the aircraft? What is the design of the wing? So you can make the suitable changes, and you can real time simulate with various types of engineering conditions of the aircraft. Similarly, EV vehicles. So you can check the performance. If the battery is full charged for the so and so battery capacity, how long it can travel. So you can't produce a car real time and check for its performance. Virtually you can create all the requirements which is required for the EV car in terms of battery, chassis, everything. And you can deploy the technical parameters, and you can analyze the performance, and you can predict whatever the problems or any issues is there. How is that possible? Only because of the decision making parameters, which will be possible only in case of digital twin technology. So, digital twin technology, it can have a better performance evaluation, it can reduce the mistakes, it can reduce the error, and it can save the huge lot of time and the resources basically, which is really required for producing real time systems. So, this is about the digital twin technology. Advantages and disadvantages of a robot. So advantages: increased efficiency, higher quality, improved working environment, increased profitability, longer working hours, prestige about the robotic system. So always they say that it's a prestige, or it's a very important part to incorporate the robot in their industry. So disadvantages: capital cost, very high initial cost, high capital cost will be there to deploy the robots, very expensive. Expertise, skilled trainers is required to operate the robots. Limitations will be there. It can only restrict to certain applications of some robots, not all. It can make jobless since you are removing the human labors from their task. Some of the macro effects can be there. Increased investment cost, so down the line maintenance issues and the other what do you say, the controllers requirement issues, or upgrading of the robotic systems, or upgrading of the software issues will occur. So these are the typical disadvantages of the robotic system. So core industrial robotic applications, what you're looking at is material handling. It can perform material handling applications. Robot can be used for loading and unloading applications of CNC systems. It can perform a welding task. Okay, so next is spray painting task. It can perform the spray painting task. So very uniformly, very precisely, it can perform the task in a short span of time. Next is very important, swarm robots. We are about to conclude, very near to the conclusion. So, what is swarm robots? Very important. So, swarm robots is nothing but it is a group of small robots where they work together. Where you can see the small robots work like social insects. Okay, it can independently be controlled. It is working. It works with decentralized control. Okay, no single master control will be there. Each robot is a self-controlled, self-operating devices, and it is also called a social insect because it can work together, and it can perform, it can coordinate with all the robots, and it can perform any type of complexity task. So it is a self-organizing robots. Scalability can be done. You can add n number of robots. You have about 1,000 robots. Again, you can multiply with other 1,000 and make it 2,000. Multiply that by again 1,000, make it 3,000. So multiple of robots can be done. Scalability is possible because it's a decentralized robotic systems, and it can perform a self centralized. It can perform the complex task coordination about itself. Robustness. What is robustness? If any one of the robot fails among this huge collection of 3,000 of robots or 4,000 of small robots, if one or two robots fails, then also the entire task will be working. Okay, so this is one of the main technical aspects of the robot that will not affect the performance parameter of the entire working of the robot. So coming to the critical applications, robot can also be used for building 3D cement blocks. Of course, yes, robot is also used for building concrete blocks layer by layer. Three-dimensional concrete block, 3D printing blocks can be done. Cement blocks can be done layer by layer by eliminating the need of the traditional framework. So labor cost and setup, the framework setup can be eliminated by using civil 3D printing robots. Next, mechanical 3D printing robots. So manually, we deploy all the design part and do it. Only if you give the design to the robotic system, So it is going to completely build. Perhaps we have to feed all the materials, and it is going to work 24 by 7, and it can also link with multiple of 3D printers. Okay, so each single robot, it can link to coordinate and link with multiple of 3D printers, and it can enable for large scale multi-axis printing applications. So it can use for CNC milling applications and printing structures, and reducing the manual labors for this applications. Again, 3D printing application is very high here. Um, Advanced dexterity. Again, we have to talk about dexterity. What is dexterity robotics? It refers to the deployment of robotic manipulators like hands. See, holding a egg, it is not an easy task, right? So you have to hold the egg, is of very specific shape, all the eggs. So you have to hold it very precisely, apply a proper required closing force. If you hold it very tight, the egg can break. If you hold it very loose also, then also it may slip and break. Even the pen, if you apply the proper amount of required pressure on the pen, it is able to apply the force on the pen nib, and it can make an imprint, or it can make an indent of the pen, and you can make the robot to make a writing of the aspect. And that is how the tactical sensing, because all these robotic sensors will be having a tactile sensors are nothing but it is arrangement of various types of pressure sensors. That pressure sensors will be able to perform a very high degree of precision holding of objects. That is what we called as advanced dexterity robots. The research is extensively going on with respect to dexterity, where it is having a very high degrees of freedom. It is not about 1, 2, 3, 4, 5 degrees. It is having a multiple degrees of freedom, and it is a very highly responsive feedback system because of tactile sensors which is attached to the robotic fingers. Coming to the end of the robotic system, here I would like to give a statement that robots is not just replacing humans or people. It is about empowering people to achieve what was once said that it is impossible, making life safer, healthier, and more productivity. So without losing jobs of human beings, so that robots can be deployed to the uh, robotic industry, all the coordinators, key members of IHE, for providing me this platform
Yeah.
to exchange the knowledge. Thank each and everyone.
Thank you so much, Dr. Rakesh sir, for such an informative and insightful session. The points shared were truly valuable, thought-provoking. Now we will move on the question answer session. Participants are requested to post their questions in the chat box, or else you can ask directly to sir. We will try to take as many questions as time permits. Participants, any questions? You can ask the sir. Participants, any questions, audience? One hand raised, sir. One person.
Yes, please.
Akash and Chaitanya.
Hi sir, I'm
Akash.
Akash.
Yes, yes, Akash.
Sir, I'm currently studying my final year Electronics and Communication Engineering.
Yes.
I'm planning to do a project on robotical arm.
Okay.
So what should I choose? Whether a prosthetic robotic arm or else the one which was like an octopus. So which one is easier to do, sir?
See, considering a regular robotic arm like links and joints with conventional robotic arms with the grippers, would be more feasible because working on the flexible robot or soft robots like the silicon robotic systems is very
Mm-hmm.
challenging, and you have lot of testing parameters, and it is very expensive at this moment of change because
Mm.
being engineering students, time parameter is very important.
Yes, sir.
So based on that, if you want to core work on soft robotics, and I would like to suggest IIT Palakkad. So you have a very important professor called as Santa Kumar. Santa
Okay,
Kumar,
sir.
who is technically working on robotics. He is a PhD in robotics, MTech in robotics. So he is working in core with respect to flexible manufacturing system. So you
Okay,
can
sir.
just connect him through mail and check out or ask his guidance if you're really interested to work in soft robotics. As of now, to work on robotics, it is very challenging, and the
Okay.
materials availability and the testing parameters may not be very feasible to complete all the aspects during your academic viewpoint. So that is
Yes, sir.
my, you can think on a small gripper, like a robotic flexible type of gripper. Select uh, what you say, flexible.
Whether a voice controlled robot or else shall I use the EMG sensors for it, sir?
So you can also use voice control type of applications, but again, depending on which type of end outcomes you're going, you can also go for that. So you can also
Okay.
go with voice enabled systems.
Okay, sir. Thank you, sir.
Thank you. Thank you all. Any questions? Abstractly concept is that where the robot can work 24 by 7. It can work without any human interventions, where you give the raw materials, and finally the finished product can become without much human interventions.
Any questions from audience? Hello, audience. Any questions from your end?
No, ma'am.
Sir, we will conclude, sir, or else?
Yes, madam. Yes.
Yeah, I would like to take this opportunity to express our sincere gratitude to our esteemed speaker, Dr. Rudresh, for Rakesh, for sharing his knowledge and expertise with us today. I also thank all the participants for their active presence and engagement, which made this session meaningful and successful. Thanks all. Thanks to the organizing team of International House of Education for their efforts in making this webinar possible. Thank you, one and all. Good night to all. Thank you, Rakesh sir. Thank you so much.
Let's we take a group photo.
Yeah, yeah. I request all the audience to switch on your cameras. We'll take one group photo. Audience, kindly switch on your cameras. Thank you, Rakesh sir. Thank you so much.